Hello, everyone, and we are back now, and we are going to get started with talking about some of the things I hear a lot when I teach lab courses. And to motivate, essentially, why are we taking this course in statistics? We became engineers because we had the option to become mathematicians, but we wanted to actually apply ourselves. So, why are we taking this course? What is the point? Well, it is a extremely important part of being an engineer. To be frank, this is a course, again, that was taught as part of one lab section when I was a student. But it really does deserve its entire semester of focus. And again, you're going to spend a lot of your career doing this work. So when I teach a lot of lab courses, I hear a lot of these questions. How good is your data? How well does your experimental data fit the theory? What is your R squared value? What's percent error? These are all very, very good questions. Or I should say, they're actually horrible questions, but they're very well-intentioned questions. But these aren't the type of questions that we should be asking ourselves as we perform experiments, as we design experiments, and more importantly, as we analyze our data. So let's take a look at this first question. How good is your data? What does this mean? Are you saying how well does it fit theory? If so, what theory are you, basing it on? Are you talking about the sensitivity? Are you talking about the trends? Again, one of the things that we're going to see in this course is language is critical when you're trying to communicate and explain your data to not only your peers, but to the general public. So how good is your data is extremely vague. What are you talking about? And again, it's not the goal of a lab or any experiment is not to replicate and get the expected answer. It's to kind of analyze and see what, the data is the data that is the data. What results did you get? How does it fit into the context of the experiment you're running? And then we can move forward. So good intention, bad question. How well does your experimental data fit theory? More focused question, but again, what theory are you comparing it to? Why are you running an experiment that has already been done potentially? Why, again, if you're asking, is it fit with your theory well? Is it the same conditions? And then again, how are you fitting it to the data? These are all good questions. R squared value. Even more specific, again, and here's one of your first statistical tools that we will utilize to some extent in this class, but again, unfortunately, and we've all been taught this way, is like R squared is not the end all be all of statistical analysis. If I have a data set here that looks like this, if I fit it, as a straight line, that may be more appropriate, but my R squared will be lower than if I fit it with a second, a 12th order polynomial. But when you're analyzing a real physical system, a 12th order polynomial is not usually physically realistic to observe a phenomenon. So again, we have to move away from an R squared is not the correct answer. We're not always trying to just get an R squared of 1. It needs to have some physical basis to it. So again, good intention, but that's not, we're working towards a much more comprehensive set of analysis and framework to basically frame our discussion. What is the percent error? I think everyone's been taught percent error. Percent error is like, I hesitate to even write it, actual over, like theoretical. But what is a theoretical value? Like, what does that actually mean? Like, how should we interpret, or what is like the actual versus true value? Like, what is a true value? If we were to measure the temperature in this room right now, we know on average we approximate the temperature as 25 C, but is it really that, So again, we are going to move away from, we're not going to ever, again, it's a pet peeve of mine. And again, we've all been taught this in chemistry and biology labs, but we are not going to do percent error. So we are going to move towards a more comprehensive statistical toolkit and basically an algorithm that we're going to use to analyze our data set. So very, very good questions, but again, this is not how we want to analyze data or how we want to start even thinking about kind of running an experiment. Because when we want to think about running an experiment, we want to have essentially these very clear goals. And even what graphs do we want to produce? Like, what's our plan? We want to have our plan, our apparatus, how are we going to collect the data, even what are the statistical analysis that we expect to perform on this, and how we're going to interpret the results, and then see what we want to have all of this done in our heads prior to running the experiment. Because we have to design the experiment to gather that particular type of data, and then the data will show us what it shows us, and then we'll hit those values. So that's how we want to go about asking kind of better questions as we run an ad for experiments. And then when we talk about, error and differences, we want to look at, there is some, effectively true value. We don't really ever know it, but we want to quantify error. What is the error in our experiments? And we're going to do that through these confidence intervals. So our data is going to fall, some probability, some measure, and X is going to fall as a distribution. There's going to be some variety of measurements. If I asked you to measure the diameters of a marble, there's going to be multiple measurements that are not going to be the same value every single time. And the tool will change your error estimate as well. But we're going to use and actually estimate that like 90% of our data will fall within these bounds, and that's how we're going to quantify essentially types of error. So we're going to build these confidence intervals. We're going to use statistical tools. We're going to use Mathematica. We're going to use R. We're going to use Python. You could use Excel to some extent, but in this course we're specifically going to focus on R. I am going to provide some Python notes because I know that some students, and we're transitioning from Fortran to Python. So I want to kind of provide that outlet for you as well. Although we're going to focus a lot on R in this course and for our project. So that's the motivation. That's what we're going to be doing. That's our whole goal. How do we run experiments? How do we analyze data? And how do we communicate that information? That's the key part of this course. So I'll see you next video. Thanks. Bye.